Alright, we're ready to begin a new module here with Module 3, and we're finally moving into a new chapter here with Chapter 2. Chapter 2 is going to focus a lot on more abstract applications for our different 6 trigonometric functions that we learned about in Chapter 1. And that's going to involve a lot of little sort of thinking problems, if you will. Different ways in which we're going to have to manipulate certain equations to get exactly what we want so we can solve for what's missing. So to kick things off, we need a lot more tools in our tool belt to kind of get there. So starting with 2.1, we're going to talk about some of the fundamental identities that we've previously seen and how they can be used to manipulate certain equations. So in section 2.1, we have a handful of objectives that we're taking a look at. First, we're going to talk about the previous fundamental trigonometric identities that we've already seen. These include things like the quotient and reciprocal identities, but also some ones that you might have forgotten, things like the cofunction identities and the Pythagorean identities as well. Once we've got those under our belt, we're going to go ahead and look at using these fundamental trigonometric identities to evaluate certain functions, simplify expressions, and rewrite expressions. All of this has the greater goal that by the end of this chapter, we want to be able to solve trigonometric equations, something that up to this point we really haven't been able to do outside of using our inverse trig functions. We want to get away from that and see if we can solve these in a standalone form. So that's kind of the goal here in this first part of Chapter 2. To kick things off, we're going to again review the previous identities that we've already seen. These are ones that previously I asked you to memorize for our earlier exams, so hopefully you haven't forgotten them. But just in case, here's a quick overview. When we're talking about our different fundamental identities, again, remember that they have a handful of things that they can do. 1, they can evaluate different functions. 2, they can simplify. 3, they can develop additional trigonometric identities, which we'll take a look at in the rest of Chapter 2. And again, the goal for Chapter 2, can we use them to solve trigonometric equations? We're going to start off small with things that are relatively simple to work with. In fact, some things that echo parts of Exam 1, and we're going to rapidly develop them into more and more complicated work. So from the first chapter, the ones that you should have already had memorized, were to start with the reciprocal identities. Sine of u is 1 over cosecant of u, cosine of u is 1 over secant of u, and so on and so forth. These are key when you're given one piece of information and asked to solve for the remaining 6 trigonometric functions. Usually you're going to need at least 2 pieces of information, but that one piece is critical. We can use it to find at least one other trigonometric value just by using the reciprocal identity. In addition, we have our quotient identities that tangent is sine over cosine, and cotangent, being the reciprocal of tangent, is cosine over sine. The ones that I didn't really drill into you as much in Exam 1, though you did use them on one of the problems, were the Pythagorean identities. The definition that sine squared u plus cosine squared u equals 1. And by taking that single Pythagorean identity and either dividing by sine squared u to get 1 plus tangent squared u equals secant squared u, or dividing by cosine squared u to get our other remaining Pythagorean identity, these are also tools at our disposal. One other thing to note is that all 3 of these Pythagorean identities can be reworked. It's kind of strange, but if we wanted to, anytime we see the number 1, we could theoretically replace it with sine squared u plus cosine squared u. Or what we're going to see in one of the later problems, we can replace 1 minus sine squared u with cosine squared u. So all of these are different things that you need to have memorized. You previously should have had them memorized for Exam 1 content, but now you're definitely going to need them to make sense of our work here in Module 3 and the Exam 3 material beside. Some other ones that we picked up in previous chapters are cofunction identities. You heard me mention this one earlier. This is the idea that cofunctions have the same value differing by, in this case, a difference with 90 degrees. So that's where we're using pi over 2 inside each of these arguments. Sine of pi over 2 minus u equals cosine of u. We saw this pretty easily with things like, okay, sine of pi over 6 is equal to cosine at pi over 3. When you take pi over 2 minus pi over 3, you get pi over 6. So it's the same basic premise. These ones don't come up as often as the ones on the previous page, but these ones below come up slightly more often than the cofunction. Those are the even and odd identities. We have 2 even trigonometric functions. They are cosine and secant. It's reciprocal. Here we can see them in the middle column. Cosine of the opposite of u equals cosine of u, and secant of the opposite of u equals secant of u. This is basically saying that when you have opposite inputs, you still have the exact same output. However, for the other 4 trigonometric functions, they are all odd functions. So in this case, an opposite input gets an opposite output. Sine of pi over 6 equals, let's see, that's going to be 1/2. So what's sine of negative pi over 6? Oh, that's negative 1/2. Opposite input gets opposite outputs. We've talked about those in previous chapters, so I'm not going to belabor the point too much. The major idea here is that these are all things that you should have previously had memorized that we're going to use to do new and better things here in this chapter. The last one that I'm going to add to this particular set that we've already seen is a slight variation on the Pythagorean identities. Sometimes you're going to see Pythagorean identities written in radical form. So this is taking those previous 3 Pythagorean identities that we saw, solving them for one of our squared trigonometric functions, and then taking the square root of the other side. So for example, if we were to take sine squared u plus cosine squared u equals 1, and subtract cosine squared u from both sides, and then take the square root of both sides, we have a radical expression for sine of u. Sine of u is plus or minus the square root of 1 minus cosine squared u. And they kind of mentioned that the sign for this final radical expression is going to depend upon what u is. Which quadrant are we going to lie in based upon our value for u? Now, while this is something that's used, this is mostly used when you're trying to find the remaining trigonometric function values. It's not really used all that often when it comes to solving trigonometric equations, which is a different topic. So while these are different ways to think about it, you're not going to see them show up that frequently, but you should know that they exist. And again, you're not necessarily going to memorize these specifically because they're just adaptations of the Pythagorean identities we've already seen. If you memorize that single Pythagorean identity, sine squared u plus cosine squared u equals 1, and how to find the other related identities, you've memorized one thing that gives you about 7, 8, or 9 different tools that you can use for other types of problems.